Hello and welcome to my YouTube channel Statistics with R. In previous video we saw how to fit simple and multiple linear regression models. In this video we are going to see how to select the variables for building regression models. And the two criteria which we are using to select the variables are AIC criteria, which stands for Akaki information criteria, which gives the estimate of a prediction error. The lower the value, the better the model is. The second criteria is the p-value, which is the statistical significance of the variables, with the help of which we include the variables into the model or we exclude it. Let's suppose we want to build the regression models with three independent variables and one response variable. To include or exclude the variables into the model, we are using three methods. The first method is the forward selection method. This method starts building the model with intercept only. Then it starts adding the variables into the model by using either AIC criteria or p-value. The backward elimination method is starting with all regressors or independent variables into the model. Then this method starts eliminating the variables one by one based on either AIC or the p-value criteria. Stepwise regression approach performs forward selection and backward elimination simultaneously to fit the model which is having the good predictive ability. In this video, we are going to see how to use all these three methods to build our regression models. And the data set we are going to use in this video is the empty cars data which is available within the R. And the variables within the empty cars are MPG, which stands for miles per gallon, and all the variables like displacement, HP stands for horsepower, drat, and the weight are the variables. And we are going to use this data set by keeping MPG as our dependent variable, and four variables which we are going to use in this video: displacement, horsepower, drat, and weight. And with the help of three methods, we are going to see that whether we have to include all the four variables into the model or we have to exclude few variables from the model. And you can check the description of the empty cards by using the question mark. Then after that you can use the empty cards data set, and you can check the description of the data set which we are using in today's video. After this, we will first try to load the one of the package which we are going to use in today's video is OLSRR package, and within this package there are the functions available for all the three methods. After loading the package, first we will try to first build the model with lm function by keeping mpg as our dependent variable, and four independent variables we are taking into the consideration. First is the displacement, then weight is there, then we have the another more variable which is the drat is there, then we have the HP stands for horsepower. So we are taking four variables into the model. Then we are mentioning the name of a data set is empty cards. We are storing this model into an object, then we will run the model. After when we have run the model by taking four variables into the model, now we will use first the forward selection criteria to see whether we have to include all the four variables into the model or we have to exclude it. For that, we are using one function which is available within this package OLSRR. The function is OLS underscore step underscore forward. So we are using first the forward selection criteria, and we have the two methods available with us on the base of AIC value and on the base of PI value. We are using the AIC value for the purpose. So we are using forward AIC value. Then we have to mention the object model which we have fitted in the previous command. Then we have the another argument, the detail argument, which is a logical statement, and we will keep it true so that we can see that at what step the model has included or excluded the variables. After running the script, as you can see, the result part is on the console portion, and it is saying the forward selection method, and we have the four variables as our independent variables. And this forward selection starts first by intercept only, and the AIC value of the model is 208.755. And the algorithm is saying if we will include weight as our independent variable, the ASC value will drop to 166.02. So the algorithm is for adding the weight as our independent variable, and the ASC value is 166.02. Now the algorithm is saying that if you include horsepower as an independent variable, the AIC value will decrease from 166 to 156. Then if we will see now when the model second has included both variables, weight and the HP, with the AIC value of 156.65. Now the algorithm is saying if we will include DR80 as our third independent variable, the ASU value will increase from 156.65 to 156.73. So the algorithm will tell you that we have no more variables to be added to the model, and this algorithm has selected only two variables in the model, weight and the HP. And then it will give the whole model summary. Then it will give the ANOVA, which will tell the overall significance. Then it would also give the estimates of every variable along with its significance. Then at the end, it will give the selection summary of the variables based on the AIC. So this is how the forward selection method works by including the variables into the model one by one. Then we are going to see how the backward eliminations method works by using the OLS step function underscore backward is the function. And here we also have two options, AIC and the p-value. We are using the AIC criteria. Then within we have to give the model object which we have fitted in the previous algorithm. Then we will put the details argument as a true, which is a logical statement. Then we will run the command. As you can see, the results are on the console portion. As you can see, our method is the backward elimination method, and it is starting with the four independent variables. It is starting with all the independent variables into the model with the ASC value 158.58. Now the algorithm is saying if you will remove first variable displacement from the model, the AIC value will decrease. So the algorithm is removing the displacement variable from the model. Now you can see we have only three variables into the model, and the value of AIC is 156.73. Now if the algorithm is saying if you will remove DR80 variable from the model, the AIC value will again decrease. So then in next step, the algorithm is removing or eliminating DRT variable, and it is now keeping only two variables in the model with AIC value 156.65. Now if the algorithm is saying if you remove HP variable from the model, the ASC value will increase. So here the algorithm will stop and it will say no more variables to be removed. So it has removed two variables from your model. And after that, it will give the final model output with all the model evaluation criteria along with the errors. Then it will give you the ANOVA, which will tell you the overall significance of regression model. Then it will give the estimates of these independent variables along with the significance. Then it will also give the backward elimination summary that if you are going with the full model, the ASC value is 1.8. Then if you are removing the displacement, the value of ASC decreases. Then if you are removing the rate variable, the ASC value also decreases. So this is how the backward elimination criteria works. Now we are going to see that how this stepwise regression works by taking forward and backward selection criteria simultaneously. We have to use OLS underscore step underscore both stands for it is taking forward and backward selection criteria into consideration. Then we will use the AIC criteria. We will again give the model object. Then we will keep the details as true. Then we will run the function. After running the function, you can see the results on the console part. Again, it will be now showing the stepwise selection method with our four candidate terms as our independent variables. Now what it's doing, it is starting the model with the intercept only with the ASC value 208. Now it is saying if you will include weight as your variable, the ASC value will decrease. So in next step, the algorithm is putting weight as an independent variable. So this is the step first and the ASC value. Now it is again putting HP variable into the model in the step second. So the ASC value is 156.65. Now the model is saying if you will include HP variable, if we will remove the existing variables from the model, the ASC value will increase. So then if you will enter the new variables into the model, the ASC value will also increase. So it is saying that no more variables to be added or removed. So stepwise regression is basically removing the variables as well as entering the variables at the same time. Now it will give the final model output, ANOVA, parameter estimate, and it will also give in the stepwise summary that which variables we have added into the model. So this is how we are performing the stepwise regression based on the AIC criteria. Now if we want to perform the same on the base of a p-value, you will use the function OLS underscore step underscore both underscore step underscore both. Then if you want to use the p-value criteria to select the variables in the model, you will select p, then you will give the model object name, then the details is true, which is a logical statement. Run the command, you will see the results on the console portion with the 4 variables. Then at the end you will see the final model output. Here you can see the final mod output that model has taken into the consideration the 2 variables weight and the HP. That means all the 3 criteria has taken 2 variables into the model to predict the mpg miles per gallon of the cars by taking weight and horsepower as an independent variable. This is how we are selecting the variables to build the models based on the 3 methods.